Okay, today we're going to start the next chapter. Since I am gone, we are not going to return your tests today. I'll give you those back next time. So the first thing you're going to do is set up your new notebook page. You're going to need one person to go get your bins from the back of the room, and then make your new pocket after the next clean page. At the top, once you make your pocket, it's going to say Unit 7 circles, just like mine. You're going to fill in your essential question with what relationships occur within circles, and then leave a spot down here for your goal. We will do your goal after we go through your Unit 6 tests that you will get back next time. Okay, so make your pocket just like that. Then you're going to flip over your page to the next clean page so we can start our notes. I'm going to close this for that. So again, you will get your test next time. This is going to be your title. Today we're going to talk about the basics of circles and all the different relationships. Today is very vocab heavy, so we will be using a different sheet to fill in your vocab. Everyone will need one of these blue sheets. You are not going to cut it. You are just going to keep it as one full piece of paper. We're going to fill in all the vocab, and then I'll show you how to put it into your notebook after we're done with that. But we're going to go through that vocab together on here. So I have different vocab, and we're going to fill in the pictures for all the different parts in your circle. Starting at the top. Feel free to pause this always if you need to catch up. Your first vocab word is circle. A circle is the set of points equidistant from a central point. We do call that central point your center. So for example, here in your picture, we will always label that center. So for example, this could be P, right here at the middle of my circle. We also name it based on the central point. So this would be circle P, because of that central point. Going to the next one. A radius is going to be a segment with one endpoint on the circle and one point in the other, showing that, at the center. So if we're keeping with calling this circle P, your radius goes from P, oopsies, to say point A right there. That is one radius. Remember, with your radii, you can have multiple all the way around your circle. They can be drawn from your center to any point along the edge. The plural here, just so that you have it, is radii with two i's at the end. Your next definition is called a chord. It is a segment with both endpoints on the circle. This, again, there's so many of these that can be drawn. You can connect any endpoint you want, or connect, your endpoints can be any part of the circle that you want. So this could be X and Y. This is one chord. I could draw another one down here. This could be A, B. You can draw infinitely many chords just anywhere you want around the circle. Next one then is getting just a little bit more specific. The diameter is again something you have seen before. It is a chord that goes through the center of the circle. Okay, so now we know our center is point P. My diameter goes straight through point P. So its endpoints are still on the circle. So you have, say, points A and B here on the circle, but now P is also a point on that segment. One thing that we already talked about too is that a diameter is exactly twice your radius. So before we said your radius went from the circle's edge to the center. Well, now since this goes through, your diameter is 2 radii. Okay, moving on. Again, feel free to pause this as we go so that you can get all the notes down. A secant is a line that intersects the circle, or a circle, in exactly 2 places, 2 points. The only difference between a secant and a chord is that my secant is a line, so it does not end on the circle. There are 2 points where it intersects the circle at, but your secants keep going forever in both directions. So the only difference between a secant and a chord is that a secant is a line and it keeps going forever. But it still intersects your circle in exactly 2 spots, just like your chords do. Similarly, we have a couple more like that. We have something called a tangent, which is a line that intersects a circle in exactly 1 location or 1 place. So we have one that intersects in 2 spots. That's called a secant. A tangent line is a line, but now it only intersects in 1 spot. So it will run right past my circle, is what it will appear to do. Okay, so this is still a line. I can label it. This might be P, this might be Q. So this is line PQ, and it is a tangent line because it is only touching the circle at this 1 point P. With that, we have what's called the point of tangency, which is the point at which a tangent line intersects a circle. So here, if I draw the exact same picture again, P is my point of tangency because that is the one point that is in common between the circle and this tangent line. Okay, then we're going to get into some more angles. So this is on the other half of your paper. A central angle is an angle with its vertex on the center of the circle. We are going to spend a lot of this chapter talking about the angles created and the different relationships, so this one is one of the important ones. So if this is still circle P, these can be segments, they can be rays, they can be lines, okay? But this angle right here is a central angle. So if I label, this could be A and B, angle APB right here is a central angle. The vertex is at the center, and the 2 segments or lines or rays, whatever they are, going outwards through the circle at some point. The next one, your inscribed angle, is an angle with its vertex on the edge of a circle. Okay, so now instead of the vertex being at the center, now your vertex of your angle is on the circle. And again, the lines creating it can be chords, they could be secant lines, you could have a secant line and a tangent line, but the important part here is that your vertex is actually on the circle. So if this is C maybe and this is A and B, angle ACB is an inscribed angle. Again, we are going to spend a lot of time talking about the different angles that happen in a circle, so for now you just need to know the vocab and what it looks like in your picture. Okay, switching over to arcs then. An arc is a portion of the edge of a circle with two endpoints. Oh, I changed colors. Okay, so maybe I have point A and point B. This, the amount connecting A and B, would be an arc. It is just a section of that. We have a symbol for this. I'm going to talk about naming it in a second. But your symbol is literally just drawing a little tiny arc, just like that. We then break our arcs into three different categories. It can be a minor arc, a major arc, or a semicircle. A minor arc is an arc with a measure less than 180 degrees. So for example, the one I drew before, that AB, I'm going to do my best to copy it, is a minor arc. Your circles in total have 360 degrees because they go all the way around in a circle. So something less than 360, less than 180 means it's less than half. Okay, when we name these, we name by your two endpoints. So for example, this one would be arc AB. So we do a little arc above it, and we just name the two endpoints. Since a minor arc is an arc with less than 180 degrees, a major arc is an arc with a measure more than, so greater than 180 degrees. So more than half. Of your circle. Okay, so again, I'm going to kind of duplicate my A and B. Okay, the major arc here would be this half. Okay, we run into a little bit of a problem differentiating between this shorter distance and this longer distance. So to name these, you now need 3 points so that I know you're going the other direction. So you will need a point, say C, right here. So you will name this with 3 points, because otherwise I won't know if it's the short one or the long one. So we will assume if you use 2 letters that it is the shortest distance between those. If you use 3 letters, your first one and your last one need to be your endpoints. So for example, you start at A, go through C, so C is next, and then finish over here at D. The last one here is going to be a semicircle. A semicircle is still an arc. It is an arc with its endpoints on a diameter. What this does is force it to be exactly half. So we have less than half, we have more than half, and we have exactly half. So for example, if I draw in a diameter, so 2 endpoints on the circle, and it goes through the center, say P. Your arc could be measured in either direction. So if you do want to specify up versus down, you will need a 3rd point. So maybe this is A and B, and then you would tell me a point C up here. So this could also be A, C, B, but since this is a diameter, this is a semicircle because it's exactly half. Oopsies. Okay, the last thing we're going to do here is reiterate some formulas that I do think you already know. Your formula for the area of a circle, if you remember, is pi r squared. This is one that should be on your reference sheet, so we're also going to fill it in here. Your circumference is equal to 2 pi r, or your pi times diameter. Your radius times 2 is equal to your diameter, which is where both these come from. Remember, circumference is the same thing as perimeter, but we call it circumference because it's a circle, so it's not a straight line distance, which is what perimeter would assume. Arc length is the last thing. It is the actual length of any arc in, say, meters or centimeters or inches. Your arc length is found by doing your circumference, so over here, times an x, that I'm going to tell you what it is in a second, and divided by 360. This x is the measure of your central angle in degrees. So in order to do this problem, you'd have to know the circumference, or so you'd have to have a radius or a diameter, as well as the measure of a central angle, and then you can find that angle measure. Okay. On that same spot, so in that space right below your formulas, we're going to fill in this example to make sure we can do it. So go ahead and draw this picture of the circle. Given to you is a diameter. So if we wanted to find the radius, we would have to cut this in half. Half of 58 is going to be 29 yards. Okay, so then if we wanted to find the area, your area is equal to pi times 29 squared, which you do need a calculator for. Okay, 29 squared is 841. Pi, use that pi button on your calculator, or you can use 3.14159 if you do not have a pi button, but you should, and on the yellow calculators they do. So you do 841 times that pi value, and you will get 2,642.07, which I'm going to round to 1 since it is area. We have yards squared. Okay, if we wanted to do circumference, you can use either the radius or the diameter to calculate it. Circumference is going to be pi times 58, which is going to be 182.2 yards. Okay, so make sure you have both of those. Once you have that filled in, shift it back over to my other screen. You're going to fold your paper in half. Just like this, and we're going to fill in examples on here. We're going to make sure you can go through and identify each piece of your circle. So fold it in half so that you're looking at this side of it. You do not need to glue it in yet. But we're going to go through and fill in these different parts of a circle. Go ahead and pause this and see if you can check with me when you're done, and see if you can name different pieces. I'm going to assume that you've had time to pause it. For center, you have two different options. Your two centers here are both point P and point X, so as long as you had one of those, you were good to go. For radius, you have a ton of options here, honestly. For radius, for example, Rx would work, Ux would work, and XY would work. In this other circle, you have PN, you have MP, and you have QP. As long as you have one of those, it's fine. Do remember that when we name it, you write the two endpoints and then you draw a segment above it. So that's super important. Going to chord next. This was when you have both endpoints on the circle. So again, there's a lot of options. Just make sure your endpoints are on the circle. We have, say, WY. We have RY. We have UY, as long as you don't name it as the line. So I'd actually avoid that one on here, just in case you think you might write it as the line on accident. We also have QR, and we have MN, and we have QN. So I'm going to pick one from the other triangle, or from the other circle this time, and we'll use MN. Diameters, there are only two drawn. You have RY and you have QN. It has to go through the center, which is why both of these are drawn to show explicitly that it goes through the center. So I'm going to use RY this time. For a secant, remember this has to be a line. So here I only see one. The only one you have that will work for secant is line UY. When you write this, I'm going to switch to the other side so I have a little more space. Make sure you put arrows on both ends, but no, it does not matter if it goes UI or YU. For a tangent, we also only have one option. We have this one right here. It touches both circles at exactly one point. Again, it needs to be a line, but you can use, say, SR, you can use ST, you can use TR. Your point of tangency, there is only one. It is this point R. For naming a minor arc, there are a bunch of options because I gave you a lot of points on each of these circles. When you pick one, just make sure that it is less than half of your circle. So say arc UY is one option here. You could also do arc QR or QM or MN. There's a lot of options in this picture. For a major arc, same thing, but you have to make sure that it's going over halfway. For a major arc, you have to name it with 3 points, not just 2. So say, for example, if I pick one up here, I could do WUY if I want to use this big portion of the circle. You have to name it with 3 points again, and you have to make sure that your endpoints are the first and last. So if I wanted WUY, it tells me to go from W through U all the way back to Y. For a semicircle, you got to make sure that you use a diameter, the endpoints of a diameter. So say if I wanted to use this one, I could do semicircle QN. So from Q to N. A central angle is an angle with its vertex on the center, so you have to use X or P here. If I use P, I could name this one angle MPN would work. And last but not least, an inscribed angle. We have one here at M, here at Q, you have one at U, or at Y. You have a couple different options here. If I go up here, I could pick angle RYW, and that would work perfect. There are a ton of options, though, here as well. Once you have that filled in, so you should have notes here, different examples, you are going to glue that in on the left-hand side of your page so that you can open up and see all your vocab words, and then you have your examples here. So go ahead and take a second to do that, and then we're going to fill in some examples. Your other examples are going to go on this right-hand side page. The other examples I'm going to give you are here, so go ahead and write down all of this. These problems are going to be a little different potentially than what you've seen before, but we are just going to utilize what you already know. So for this problem, I want to find the diameter, but I am given the circumference. So this is the opposite of regularly what we have done before, where before we give you the diameter and ask you to find the circumference. Now we're going to turn that around a little bit. First off, you've got to figure out what formula you are looking at. We want the circumference formula, which you are given to, if you recall. We know that the circumference is equal to 2 pi r. We also know that the circumference is equal to pi times diameter. Now you can use either one here. However, I like to think about what makes the most amount of sense. Since I want the diameter, I'm going to use the one that involves diameter. So this time I'm not going to use that one, but you can absolutely use either. Once you've picked your formula, you got to plug into your formula. I was given the circumference, so this 65.97. It's going to get plugged in right here for the C is equal to pi times diameter. Once you have that, we got to solve for diameter. While pi is a symbol, it is still just a number. So you are going to divide both sides by pi. Your calculator can do that for you. Make sure you are doing that now. And you should get that your diameter is 21 meters. Again, as before, either use your pi button on your calculator if you do not have one. This is the shortened version you need to use, 3.14159. Okay, we're going to go ahead and try this one. So again, feel free to pause the video so that you have time to write this down. but this is going to be very, very similar to what we just did a second ago. Okay. Again, you have to figure out what formula you're talking about. We are given area, so I'm going to start by writing down my area formula. And I'm going to plug in what I was given here. Since there's only one area formula, you do not have to think as much about which one to use and debate like we did on circumference. Okay, but my area equals pi r squared. Once you have that, you are again going to divide by your pi, and my r squared is equal to 121. Thinking back to last semester, when you have a squared, the way you undo it is by square rooting both sides of your problem. Again, that's for your calculator to do. Your r is equal to 11 inches. So on your calculator, you should be hitting the square root button to find that answer. The last problem we're going to do today is this one. This pi, my computer didn't have the button, so you are welcome to just write this as 26 pi. That's how you spell it. My computer didn't have the button to type it in on this program. Okay. This one's a little bit different. I want you to find the area, and I gave you the circumference. So you do need to start over here with what I gave you in your circumference of 26 pi. Sometimes I'm going to give you exact values like this. While it may look trickier, I promise it actually makes it a little bit easier. For circumference, again, we have two formulas. We have 2 pi r, and we have circumference equals pi times diameter. One thing that can help here is to think about where you're going with your area. Since I'm going to eventually find area, I know I need my radius. Okay, so while yes, you can find your radius from either of these formulas, the one that will get you directly there is going to be your 2 pi r. So if I plug into this, I have 26 pi equals 2 pi r. When you divide by pi, these are just going to cancel each other out. And you get 2 radius equals 26. Yes, you can divide by that all the way through. I just wanted to make sure you could see what was happening. When we divide by 2 here, my radius is 13 feet. Then when we shift gears a little bit and go to my area formula, because you got to go over there to finish it completely, we're going to plug in 13. Doing pi times 13 squared, you're going to get 169 pi, which is 530.93 feet, or just 0.9 feet. Okay, that is the rest of your notes for today. At this point, you are going to be given your homework and have plenty of time to work on that. If there is anything you need to rewatch in here, feel free to rewind it, go back and watch it over. This is on Canvas, so you will have access to it there as well. This homework will be due next time, and we will also be going over your test next class when I return.